Hello guys, so today we're gonna solve this problem of 647, palindromic substrings on LeetCode. So I've solved this problem and it is a medium problem. Let's see, I've solved this problem, I don't know when was the last time I solved this problem, I don't remember. So given a string S, return the number of palindromic substrings in it. Okay, a string is a palindrome, I know I'm assuming and we all know what the substring is. Okay. So we need to basically count the number of palindromic substrings in a string. So we can see A, B, C, there are three palindromes. A, B, and C, there are no other palindromes. A. So we need to count how many palindromes there. Case in this case will be it's A, and A. So 1, 2, 3, then 1, 2, and 3, 4, and then 5. Wait, what? 1, 2, 3, 4, 5, and then 6. Yeah. There are 6 palindromic substrings, right? Yep. Okay. So I have recently solved the problem of let's just solve this problem. Let's assume that you're solving this problem now. So the how many what is the length we are given to us? 3. Okay, so if you want to find palindromic substrings, the most I think the basic idea which comes into our mind is you know have you odd and even length problem if you remember that. Well, it wasn't that, it was counting, it was getting the max. There is one problem on LeetCode which is, I think, problem number 5, in which we need to figure out the largest, longest palindromic substring. So, in that problem, we use the concept of odd and even lengths. We are first getting an odd length palindromic and even length, and then we are getting the maximum which we can get. Basically, we are considering a palindrome from the middle instead of considering instead of we are considering a string from the middle, getting a character of the string in the middle, and then expanding to see if it is a palindrome or not. So now but in this we have to count how many palindromes are there. The first basic idea which comes into our mind is for example, let's consider this palindrome A, B, A, C, and let's just put another A over here. Let's assume this is the string S given to us. Right, so we can see that there's one palindrome, there's another palindrome, ABA, ACA. These are two separate palindromes, and then all of these individual characters are also palindromes. So I can see there are 7 palindromes in this problem. So the thing that gets in order for us to solve this problem is I feel like we can start considering that this and the time complexity of this problem of getting the largest is big O of n square. So similarly, if we are counting a palindrome, this problem will also have big O of n square. We don't actually have to return the string, which each string we just have to return the count, right? Yeah. So this seems to be a little easy problem on one hand because we can consider this is a palindrome and move this and this way to see if it is. Yeah, I think I'm gonna go with this solution only because I recently solved this and I remember this problem. So I can't think of any other problem or idea to solve that. So is there any other thing that I can consider every substring? For example, like this, I'm gonna loop over A, B, C, it's a palindrome. Well, this is a palindrome, this not. This is a palindrome, this not. So that will be big of n square. Yeah, actually, let's do that only. But when I'm going over here, I'll have to find out the substring and getting a substring or checking a substring is a palindrome will take big of n time, right? I think the what is the time complexity of substring? Time complexity of substring function, right? Substring function in C++. Time complexity big of n, right? Yeah, seeing that time complexity is big of n. Sorry, guys. Yeah, there it is. So the time complexity of that function is big of n, and I hope I haven't shown any sensitive content to you. Well, no one's watching my videos anyway. So big of n square. And when I'm considering so then I think the best case would be to solve this problem that way only. Yeah, that's what I think is the best way to solve this problem. For int I equal to 0, I less than s, that's it. So in this way, in this problem, I'm gonna loop over all the elements, then I'm gonna consider an odd length substring, and then I will consider an even length substring, right? So let's go with an odd length. If there's an odd length, I'm gonna the current element which I'm on using the outer loop, the first loop, I will consider that as the middle element of the palindromic substring of the substring that I will form. So int left, let's just assume as I, and similarly with right is equal to I, right? And now I'm going to expand and check while it is a palindrome, while left is greater than equal to 0, right is less than n, and s of left is equal to s of right. So while that thing is happening with us, it is good because till then I have a palindrome. So if I have a palindrome, I'll simply do count plus plus. Now I'll do int count, which is equal to 0. Count plus plus. Now I will do left minus minus and right plus plus. Yeah, and similarly when in the next one I will do left. I'll keep left as I, but right is equal to I plus 1. One more thing here to note is that I'm considering like all the even and odd cases at a one go. Like when I'm traversing the string, I am considering that if that element will be length odd one substring, or it will be a part of a even palindromic substring. That is it's a very beautiful solution. I feel like very difficult to come up with if you're solving this on your own. Like I wouldn't have come up. I literally looked at a solution and I remember this. That's how I'm able to come up with it. And I can definitely wrap this in a function to avoid, writing it twice. But now that I have done it, I'm just gonna keep on doing it. And this actually this code is actually has taken the inspiration from LeetCode guy. That guy is brilliant. I'm just doing this for my own purpose. I'm not here to teach. I'm just doing this so that I can learn myself. This is how I'm hoping I can maintain consistency in my LeetCode journey. Yeah, when I'm doing count plus plus, yeah, at the end I have to return count. This should work just fine, I feel. Perfect. See, two solutions that pass. Let's see the time complexity with which I end this problem, 93. Great. Now I want to see the solution that I've done. Wow, I solved this on 10 February. Way long. And how did I solve this problem? Wait, what? I have written. Wait, why am I feeling that? Oh yeah, actually same solution, guy. This is the same solution. Now here I've considered, yeah, like I was telling to complete and compile them in a function, wrap them in a function. This is what I've done here. And if I look at this solution, that the memory is too long. Yeah, this is what I was doing, right? I was looping to maybe this function. Now I'm considering if it is a substring. So it's basically checking. So basically I was looking here if it is a substring, right? So I'm going to consider every substring, then check if it is substring. Yeah. Oh, wait, what was I thinking of making? So, wait, I am checking. And so, yeah, the time complexity is big of n cube in the worst case. And wait, how did it pass? What was the time solution of this? Yeah, 13. Oh, exactly. It's not a good solution, right? Because, wait, wait, it's because I'm considering every substring, and then I'm again looping over that substring. Yeah, right. I'm doing a big of n, so it can go to big of n cube complexity for. So it can raise a TLE, but luckily it didn't. See, it's taken 35 minutes to solve this one. And what? Achha, wait, the time was that the time that I took to solve that problem. Maybe. Wait, why is this? Don't know. What's up with that? Anyways, I think the time this one is a better idea. Yeah, thank you guys for watching this video. You could have left, you could have, this is what I wanted to share, and yeah, that's it. Just I'm closing now. Bye bye.